Welcome to the presentation about end-to-end UAV simulation for visual SLAM and navigation. To begin with, let us look at a typical visual navigation system. The system perceives the environment and reacts to it accordingly, so that the UAV can safely move from one place to another, even in an unknown environment. Typically, a localization kit, a mapping kit, and a planning kit are integrated into such a system. The localization kit estimates the pose from the onboard cameras. With the estimated pose and the depth input, the mapping kit reconstructs the environment. Based on the reconstructed map, the planning kit dynamically plans the trajectory to the destination. Verifying such a system under realistic scenario can be effort-intensive. Simulation is an alternative solution. The motivation of this work is to construct the end-to-end simulation environment for research and education purpose. Here, end-to-end refers to the capability of verifying all the perception, reaction, and control algorithms in one simulator. This figure is an overview of the simulation system. The system is based on the ROS Gazebo PX4 toolchain. The exchange of the information between different keys is coordinated by ROS messages. To support the visual pose estimation, we added the stereo visual inertial perception sensor to the original ERIS UAV model. And we also designed a 20 by 20 meter simulation world and furnitured it with wallpapers. Here, we demonstrate the manual exploration of the environment. The localization and mapping kits are enabled in this case. The left part is the gazebo view, and the right part is the RVS view. Inside the RVS view, there exists the colored image, the depth image, and the output image from the localization kit. We can also observe paths and reconstructed map in the map view. To evaluate the system performance, we plot the ground truth path and the estimate path from the localization kit. The total length of the path is 83 meters, and the absolute translation error is less than 0.3 meters. Besides, good agreement between the simulation world and reconstructed map can be observed, which means that the localization and mapping kits work out fine in the simulator. Here, we demonstrate the click and fly autonomy. In this case, we further integrated the path planning kit into the simulation. The difference is that here we only give a desired destination on the map to the UAV. The UAV will plan the path, avoid the obstacle, and fly to the destination automatically. The source code of simulator setup, localization, mapping, and planning kits are now available. Thanks for watching.